and going on to the next, so we would have seen that, okay, this is the first one, no problem. I've seen that when I have, recap, a 1 and a plus sign, then I think in the direction of tan inverse, okay? If I can isolate to have a 1, if I have a 1 on top and like a positive sign there at the bottom and then x squared, then I'm going to think in the direction of tan inverse. Now, what about if I have an x on top and I have this x squared? What is it going to be like? Well, if you have an x on top, then you are going to think in the direction of ln x, because the top would be the derivative of the bottom. If I differentiate an x squared, I'll get an x. It's not really x, it's going to be 2x, but it's a type of x, okay? We don't care about coefficients, but 2's and the 3's and the whatever's that will be in front. Those don't change nothing. We're talking about the power. The power is the one. Because coefficients, we can bring them out, take them in, bring them out. They're not even a big thing. So when I have here an x and I have an x squared here, then I can say, okay, the top is the derivative of the bottom. So I'm going to use the idea of ln x. I'm going to integrate it to go give me ln x. Because I know that the integral of, let's start with the derivative. The derivative of ln f of x is going to be the derivative of f of x over f of x itself. We know this. So we know that the integral of the derivative over the original function should take us back. Okay, if we integrate with respect to x, it should take us back, but we have to put modular signs, by the way. Remember that. When you integrate, you go there. And we can put your constant of integration. See, but it should take us back, because now integration takes us back to where we were before we differentiated. Okay, that is it. Now let's work on it. So I have the integral of the derivative over the original function, and I know I should get an ln x. So let's do that. I'm going to take this guy, and that is just what it's going to be. So it's going to be the integral of x over x squared plus 1 with respect to x. Yes, and of course I'm going to use those ideas of letting f of x be this and then whatever. So I would say, remember that you can say for the integral of this, you can say let f of x, okay, you know that, let f of x be the smaller x squared plus 1, okay? Then I'm going to find f dash x. F of x is the denominator. It's always the denominator. And you now find f dash x, which is going to be 2x, right? This is going to be 2x. So because the derivative of x squared, you drop down the power, it's 2, you use it by 1, it becomes 2x, and the derivative of 1 is 0. So now what am I going to do? I need to make the top be at 2x. Because I can be able to then substitute with these two. That's all I need to do. So I'm going to say the integral of x over x squared plus 1 with respect to x. Now I know what to make the top be. What am I going to do? I have to make it a 2x. So how would I do it? I'm going to say half, come outside please. Okay, the half. If you want, you can start by putting the half on top. Half, and then you have 2x, so half times 2x. If you put 2x and half, it's like you have done nothing, right? O over x squared plus 1. We are integrating this whole thing with respect to x. And since the half is just multiplying, it can go outside. So half integral of 2x over x squared plus 1 with respect to x. And now we know that this is the integral of f dash x over f of x, okay? So this is going to be half the integral of, we now know that integral. So this just goes to half ln of x squared plus 1. And then you put plus your constant of integration, c, because it should go back to ln f of x, and the f of x is just this. And this would be your solution, right? I use the idea of logarithms. Why? I have an x squared, yes, but then there's a derivative of it on the top. Now we go to the last example. I'll do it in a separate video, although we've done it, but we'll do it again. And it just kind of is bringing you back to see how you would think in this situation, because you are going to get a situation and you must be ready for it. You must be knowing your thought process, how you analyze the different methods and see that, oh, this one ain't gonna work, so whatever. Now let's do that next one. Goodbye.